Numpy.Unique has a problem with Frozensets. Just run the code. The first out is correct, the second is not. The problem exactly is here. But set from np.unique has 3 elements, not 2. I used to utilize np.unique to work with duplicates for x, using return_index equals true and others. What can you advise for me to use instead np.unique for these purposes?
Numpy.Unique operates by sorting, then collapsing runs of identical elements. Per the doc string, returns the sorted unique elements of an array. The sorted part implies it's using a sort collapse adjacent technique, similar to what the next sort, unique pipeline accomplishes. The problem is that while Frozenset does define _p_, the overload for less than which most Python sorting algorithms use as their basic building block, it's not using it for the purposes of a total ordering like numbers and sequences use it. It's overloaded to test is a proper subset of, not including direct equality. So Frozenset 1.2 is lower than Frozenset 3.4 is false, and so is Frozenset 3.4 is greater than Frozenset 1.2. Because the expected sort invariant is broken, sorting sequences of set-like objects produces implementation-specific and largely useless results. Uniquifying strategies based on sorting will typically fail under those conditions. One possible result is that it will find the sequence to be sorted in order, or reverse order already, since each element is less than both the prior and subsequent elements. If it determines it to be in order, nothing changes. If it's in reverse order, it swaps the element order, but in this case that's indistinguishable from preserving order. Then it removes adjacent duplicates. Since post-sort, all duplicates should be grouped together, finds none, the duplicates aren't adjacent, and returns the original data. For Frozensets, you probably want to use hash-based unification, for example via set_or, to preserve original order of appearance on Python 3.7 plus dict.fromkeys. The latter would be simply It's also possible to use sort-based unification, but Numpy.Unique doesn't seem to support a key function, so it's easier to stick to Python built-in tools. That second line is a little dense, so I'll break it up. Sorted A, key equals sorted, returns a new list based on A where each element is sorted based on the sorted list form of the element, so the is lower than comparison actually does put like with like. Group B, returns an iterator of key/group iterator pairs. With no key argument to group B, it just means each key is a unique value, and the group iterator produces that value as many times as it was seen. K for K underscore in ... Since we don't care how many times each duplicate value was seen, so we ignore the group iterator, assigning to underscore means ignored by convention, and have the list comprehension produce only the keys, the unique values.
If you want to support the channel, please consider subscribing.